Vector notation can get a little bit complicated, but once you get the hang of it, it's fairly simple to comprehend. When we're talking about vector notation, we have the A and the B. So if you look here, I'm starting at the origin. This is going to be my vector V. It's going to end up here at point A and B. Well, those, in order to create this point, has their own components. So just like with trig, when you draw triangles to do your reference angles, and we draw them on the coordinate plane, we kind of use that same idea when we're working with vectors. So here, this is going to be, say, our B component. And this along the bottom here would be the A component. So with that, A is going to be the scalar where we call it horizontal. And B is going to be the scalar vertical. With that, our notation says you're going to put this sideways V, then you're going to write your points A, comma, B, and close it. So instead of having smooth parentheses, we've got these very sharp looking parentheses here. And in this case, when we talk about scalar, we need to remember that scalar means value or number value. It does not mean vector value. Okay, so we're talking about something completely different. Now with that, we have what's called component form. So in order to look at component form, let's look at an example here. So if we have that A is going to be the point xy, and we have C, which is the point x2, y2, your component form of vector AC, okay, is going to be sharp, I guess, sharp parenthesis or sharp bracket, however you want to call it. And we're going to have x2 minus x, comma, y2 minus y, and close it. So what you need to notice here, okay, so what we want to note about component form is that since C is the end of the vector, we will use this point values first. So if you look very carefully, I'm talking about the vector AC, but when we find it, it's kind of like when we did distance formula, or when you do slope, you use the second point first and the first point second. We're kind of using that same idea here. So you can see I'm starting at A, I'm going to C, so the C values go first, the A values go last. Okay. Now when we're looking at the length of a vector or the magnitude, let's say we are given vector V is equal to V1, comma, V2. Then your magnitude, which remember we denote double bars, V double bars, would be the square root of V1 squared plus V2 squared. Okay, so these are the formulas that you need to remember. Again, we have component form and we have magnitude. Okay, and notice with both of these you were given your vector first. Alright, let's look at a couple examples just to make sure that we are all on the same page, all on the right track here. So we have, find the component form of the vector given the initial point and the terminal point. Find the magnitude of the vector. So here we have vector FE, and we're told that E is the point 0.84 and F is the point 11, -2. So I always like to start by making sure I draw out my vector for myself. So I'm going to go ahead and draw a vector here. If you remember, my vector is supposed to go FE, and I'm told that F is the point 11, -2, and E is the point 0.84. So drawing out your vector and putting that arrow in there is really going to help you, especially when working with component form and your magnitude form. So here I have to be able to do both. So first let's look at component form. So to do that says again, I'm going to start, and you start with your second. So here I'm going to have 8 minus 11, so this is going to be 8 minus 11 for the first part, and then it's going to be 4 minus a -2 for the second part. So here we're actually going to do the math. So 8 minus 11 is -3, 4 plus 2 is 6, and that is your component form. Now the last piece we have to do is magnitude. So I'm looking at the magnitude of my vector FE. And so again here, this is going to be the square root of V1 squared plus V2 squared. So we're going to use these values. So here, what do we know? We know this right here is my V1, and this one right here is going to be V2. So this is going to be the square root of -3 squared plus 6 squared. So we're going to have here the square root of 9 plus 36, which is going to give me 3 square roots of 5. Alright, what happens if we are asked to do everything I just did, but all we are given is the graph? Well, the first thing that you have to do is you have to identify this point here that I'm starting at and this point here that I'm ending at. So I'm starting here, I'm going to go over 1 and 1, 2, 3, 4, so this is going to be the point 1, -4. And then for this point I went over 1 and down 1. So here this is going to be -1, -1. So I have my two vectors. So the first thing I need to do is component form. Again, component form says you're going to start with your x values, and we're going to start with the ending point, so -1, and then we're going to come down -1 and comma, and then do it again, -1 minus a -4, and close it. So in this case, what we get is we get -2, 3. Again, if you remember, that makes this first term V1, it makes the second term V2, which allows me to find my magnitude. So, my magnitude, okay, again, says that I'm going to do the square root of v1 squared plus v2 squared. So this is the square root of negative 2 squared plus 3 squared. So this is going to be 4 plus 9, which is going to equal the square root of 13. And that is everything you need to know to get started with magnitude and component form of your vectors. So if you have any questions, please let me know. Otherwise, I can't wait to see you next time.